Right, today we're going to go through a question on energy bonds and then energy changes in exo-endothermic reactions. I'm going to show techniques of how I teach students how to correctly calculate energy bonds without making too many silly mistakes. So a typical question will have obviously a chemical reaction. They'll have an equation. Please be aware, I don't know why there's a 3 mark there, but it should be an arrow, never do equals marks. And then they will have a display of all the bonds within that chemical reaction and a table summarising the bond energies. You will never you will never have to learn these values. They are always given to you. So my technique is, as you can see, I have crossed off every bond that I have accounted for here. So I put an R here for my reactants and a product here for my products, and either side I can tally up how many of the different types of bonds each side has. So I haven't done this last one here. So here there's 2 oxygen hydrogen bonds, so there's 2 of those, but we have 4 molecules of water, so that times by 4 equals 8. So I summarise it on there, making it a little bit simpler for me. And then underneath, I spread out the reactants and the products. You have to multiply the total energy with the number of bonds there are. Simplify it like that so the examiner can see what you're doing as well. Keep it neat and simple as possible. And then just add them up. And for this, the reactants, the total energy for the reactants is 5,613 kilojoules per mole. The units are here, if you're wondering where I got that from. And then on the product side, there's only 2 types of bonds. You add those up and it's 6,932. Now to work out the change in energy, all you need to remember is you take your reactants and subtract your product energy. So in this case, we end up with a negative value. Now this, if we can simplify it, something to remember, if your energy change is negative, that means it's an exothermic reaction. Remember, exo means that the energy exits, EX, the reaction. If your energy change is positive, then it's endothermic, and that means your energy has to come in from the surrounding area. It enters that reaction to take place. The second part of the question will look something like this possibly. So 2B here was explain why, in terms of bonds, breaking and forming the combustion of methanol is an exothermic reaction. It's only 1 mark, so you need the correct details here. So you need to refer in your answer about breaking and forming. So writing something like this, that more energy released when products formed compared to energy needed to break reactant bonds. So I've used break and form in there, and that tells you why it's an exothermic reaction. And then very often they will ask you to complete an energy profile. So you've got to know the difference between how your exothermic energy profile looks. And here I've done an additional one for endothermic to show you here. But if we focus on the exothermic, which is what they're requesting, they have given you a list of everything they want on that diagram. So you need to label the products, which in this case you have to do the formulas for them, like they have for the reactants. Just copy the format and then draw your increase and then decrease and then to a line. You can use a ruler if you want. The overall energy change. So the overall energy change goes from the level of the reactants to the level of the products. For the exothermic, that means it's going down. That is why you've got a negative energy change. That's why it's negative here. And then label your activation energy. That's going from your reactant line up to the peak of your curve. So that is your activation energy, and label that as well so that the examiner knows exactly that you know where the activation energy is and you know what the overall energy change is here. So you label that there as well. Now, in comparison, I'm just adding this on. Your endothermic, your reactants, whatever they might be, are listed here. Your product line, with all your products listed there, is going to be higher. You still do a very similar curve round. This time your activation energy is going to be a lot more, but it goes again from the reactant line up, and then your change in energy again from the reactant line to the product line, it's going to be a positive one because it's going up, and that's why your energy bonds calculation is positive for endothermic. I've also added here something to put on flashcards if necessary. Your typical exothermic reactions are combustion and neutralization, typical endo, electrolysis and thermal decomposition.